Okay, I should be live on both the platforms. Let me just cross check. Yes, I am live. Let me just tweet and then we can move on to today's agenda, which is okay. I guess, yeah, I have posted it and everything is good to go. Yes. So we yesterday we read about ERC 7683. So it's here, right? Uh, this across protocol is using it in the production. So that's what we're gonna learn, like how it works, what are the differences from regular bridging to bridging with intents. But we can start with like actually bridging it. Um, what was testnet across protocol? Okay, so if we are like going through docs, we should actually use it. Otherwise, we won't know how it actually works. So I'm using Sapolia, base Sapolia, and let's try bridging max. Okay, we can't bridge. I knew that. I just wanted the amount 85 to arbitrum. Okay, bridge fee 1 cent, destination gas 0.07. Okay, that's that's fine. We are transferring $7.8 worth of this ETH, and we are getting across is charging 8 cents. So it's like 1% or less than that. And across is not charging. Let me correct that. Across is only charging 1 cent, and the rest is actual the gas fees. Yeah, and this goes to liquidity provider and relays. Okay, so I don't know how much is that. 0.01 divided by 7.8. Yes, it's like 0.1%. That's great. Let's actually transfer it. You won't see the pop-up, so ignore that. I just confirmed it. It takes a while on testnet, I think. It's much quicker on the mainnet compared to testnet. It won't take 17 seconds. Okay, anyone watching on Twitter? No, not many people here today. Let's see. Okay, I don't know why it shouldn't take this long. These things happen on testnet because there are not a lot of relayers here. Maybe that's why it's taking that long. But we should be able to see these things soon. Arbitrum. Okay, we got the fill. So you can continue. You can see we deposited this. This was our transfer. And yeah, 11 seconds ago. This is where we are sending, and this is where we are receiving the transfer. Depositor, recipient, input token address, output token address. I don't know, it's ETH only, right? Then why there is output token and input token? It should be like native and 0 address. Okay. We amount, where is token? Output token. Yeah, this input is this. I'm not sure why there is input and output token for some reason, because we sent ETH and we received ETH, right? So there shouldn't be any, but okay, there is. Ignore. We'll understand why it is this way. We got this. Okay, we can, at least we tried, like how and saw how it works. So that's what I wanted to show you. Ignore this timing because it's a test net. Maybe that's why there are delays on mainnet. Like it's very quick. I have tried it, like I have used it, and it's not this like more than a minute for most of the chains. I can't guarantee you like it's for all of the chains because I haven't tried it, but for the ones I have tried, it's very quick. Okay, so now that we saw this, we are going to go through the docs and uh, basically read it, read most of the docs and see how things work. So we know we are the end users. There is a contract, settler contract, and there are relayers who are filling in these intents. So that's what we want to learn, like how all of these things fit together, and we are gonna create like Excalibur outline, uh, how it works across protocol architecture. Both of us don't doesn't know like how it works, and that's where like that's what we are doing on the stream. We are learning uh, live here. So okay, maybe I should like zoom in. If you guys can't see, if anyone is watching, like let me know if you can see or not. Hi everyone. Okay, so welcome to Across. Across is the fastest, cheapest, and fastest, cheapest, most secure decentralized way to bridge and execute transactions cross chain. Across, I know it's fastest and cheapest, most secure. I don't know how it works, so we're gonna take their word for it. And decentralized, yes, based on what we learned from 7683, yeah, it's very much decentralized. But we don't know how the filler network works. So, is it gated right now? Is it open to anyone? That's what we want to talk about. And yeah, relayer. This is the part which is interesting to us because we can run our own relayer for a particular asset, and it's not that heavy. That we don't need a powerful VPS to run this. We just need assets, and hopefully we get nominated. Like there is nomination. They are saying it. We will go through it and learn how the nomination works, and hopefully we can run it. I don't know if someone from across is watching. Let me know if I can run my own relayer and start earning fees from it, or is it just the team running relayer? Not team, but team and the market makers running these relayers to get to fill the intents. Okay, back to our first page. Across is an interoperability protocol powered by intents. It's the first cross-chain intent protocol in production today, enabling the fastest, lowest cost way to transfer values with better security trade-offs versus traditional bridge designs. Across is perfect place for users to bridge funds cheaply, quickly, and securely. Uh, yeah, securely. Developers, I am reading it wrong. Across is the perfect place for users to bridge funds cheaply, quickly, and securely. Developers to build production ready cross-chain apps. Okay, there is some and or something is missing there. Quick starter. Pick your learning path and learn how Across allows you to ship cross-chain app in the fastest and easiest way possible. We What should we do? We don't want SDK. We don't want API. Okay. Across can be easily integrated via our easy to use REST API in an application requiring instant low cost cross chain value transfer. Let users onboard assets without leaving your app. Okay. It's API reference. We have testnet across endpoints, suggested fees, optional override, the relay address used to call that. Okay, ignore that. Yeah, start with bridge integration guide progress to learn how you can make multi-chain and single chain experiences. Okay. Embedded cross-chain actions. Build seamless taking, minting more and more functionalities where bridging is abstracted away with across. Concepts: generic multi-handler, multi-call, multi-caller handler, custom multi-caller handler. Okay. So yesterday we learned about legs, right? Legs are intent can have multiple actions in it, and each action is called leg. Or that was our understanding. And I guess this is for executing each leg. Yeah. Learn how across works. Yep. This today we want to go through this. Deep dive into across and learn about various actors that help build the fastest, most secure, low cost, and decentralized intent based interoperable protocol. Great. Relayers grow, join the growing network of independent relayer, earn up to 100% API. That's what we are talking about. But still, um, the more intents we fill, more money we get. That's not like passive. Something like Aave where we just put money and we grow it. We actually have to run the relay, and then understand the whole thing. Contract chain. So it tells sub chains. Yeah, there are multiple chains here. Are all of them EVM compatible, or I'm not sure if all of them are or they are not. Anyway, uh, we can go here. It doesn't matter. We want to go on this page. Yes, concepts. We will go through these four and take notes and create the outline with this. What are cross-chain intents? What are intents? An intent is type of order where user specifies an outcome instead of an execution path. So it's telling if we let's read the whole thing. Intents can be single chain or cross chain where users desired outcome is on different chain than input assets. Across is only focused on cross chain intents. Okay, why single chain? Why would someone do the single chain? Like, isn't that called a transaction or multi call transaction where we just set we just give all the call data for each call and we create a transaction. And single chain intent is just a single transaction where multiple calls are happening. Multi cross chain intents is something useful. We see the progression of cross chain intents in the following way. Okay. Phase 1, users intent specifies users intent specifies moving the same asset from chain A to chain B. This is what Across started with and has been supporting since 2021. Great. Phase 2, users intent specifies moving same asset from chain A to chain B and then executing transaction on chain B. This is enabled in Across by new functionality to embed instructions on the origin deposit to be executed on destination. So for first, it's just like you get the data and you get the asset and you send the asset. There is nothing else. Second, you get the asset and tell like do X, Y, and Z. Like a swap, if you have some swap, uh, some action like mint or swap, it'll do that. That's what it's saying. Okay, we don't want to go here right now. Okay, uh, phase 3, users intent specifies swapping asset X on chain A for minimum amount of asset Y on chain B, and then executing a transaction on chain B. So swap USDC for ETH on Arbitrum and go to Optimism, take that ETH and mint a NFT. That's yeah, that's the idea. So we understood like different phases of intents and what they went through. First, it was just one asset from one chain to another, then one asset from one chain to another, and a transaction execution. And third phase is asset 1 on chain 1 to asset 2 on chain 2, and use that and execute a transaction on chain 2. Okay, these are three different things. To grow the adoption of interoperability solution powered by intents, Across is working on defining a cross-chain intent order standard based on concepts outlined in phase 3 above. Okay, so that's what we learned yesterday, uh, the structure of the order, uh, not the execution but actual structure. This will enable a unified way to bed bid on ingest, bid on, escrow, and settle user intent. See more. Okay, will we have seen it, now we want to see it in production. Okay, let me yeah okay, now we want this intent architecture in across I don't know, across intents architecture. Across cross-chain intents architecture can be distilled into three-layered system: a request for quote mechanism to house users intent, enabling a competitive network of relayers. I don't know, we can't click it. Okay, just it's just color, it's not a link. Yeah, here. And then enabling a competitive network of relayers to bid, claim and fill these orders, and lastly a settlement layer to verify intent fulfillment and repay relayers. Below is below is a diagram of planned architecture of Across after implementing a request for quote auction to enable gasless orders and cross-chain swaps. So let's open this. User has user signs an order, so that's the intent. It why it's getting sent to relayer first, I don't know. Claim order deposit bond, uh, we send it here. Spoke pulls token from user. Okay, so it basically escrows it. Then third, what is third? Transfer funds to user. Spoke pull does it. Oh no, it relayer fills the order, so it sends it to the contract. Contract sends the funds to user. Then fourth is propose bundle. I don't know what this bundle is. Then we have re- repay instruction. Why it's getting repay on both sides? Okay, it depends on what's happening, where we are, where the relayer is telling to get the assets from. So if it wants on origin chain, we are paying on origin or destination. We need to understand the data worker, what this is, and how this middle part works, because this middle part is important for decentralization. Uh, Intent, like checking intent is there, the escrow is there, and then checking intent is filled, and telling origin spoke pool contract that intent is filled and you should repay. So that's the part we need to understand. Yes, let's understand what the team is telling, like how it works. User requests codes to fill their intent. User receives a code from relayer to fill their order and signs no on-chain transaction. Okay, so it's just regular like signature, and then we get a code like how much we are getting on destination chain. Across current RFQ implementation does not include gasless orders or cross-chain swaps via RFQ as depicted in step 1, 2A, 2B, though these are planned upgrades. Okay, understood. Across this quote currently has a fixed fee, and relay competition is strictly based on speed. All other steps are identical to across current architecture. Okay. Relay network. Relay network fills user. 2A, relay claims the order and the executes the sign order. B, bringing the transaction on chain and users assets. So it's this part. No, that's not the case, I guess. Which one is the B? There is 2B, but not just. Okay, and users' assets are escrowed via spoke pool. The structure of orders can be found in intent lifecycle. That's the next article. 3A. Oh, yes. It's 2A. So 2A is like claim, and then 2B is bringing on chain. I was correct. Then 3A. This relay calls the fill relay v3 on destination spoke pool with their own assets, which 3B are then transferred to users. During this step, relayers also specify which chain to take repayment on. Understood. Okay. The repayment chain choice affects the portion of relay fees paid out to liquidity provider. We need to understand this, but not right now. Settlement system. Settlement system verifies fill and repays relay. Over 60-minute window, the data worker ingests deposit events. 60 minutes. deposit events matches them to valid fill events, i.e. fills that met the intent order requirement. All valid fills are aggregated into a relay repayment bundle. Okay, that's the bundle they are talking about, and optimistically proposed for verification. If no disputes occur during challenge period, the data worker executes the bundle on hub pool, which then routes repayment instructions to various spoke pools to repay relays. Relays are repaid after a short delay. So I don't understand if there is 60-minute window, like to get the money back for users, because that's for relays, or does it happen quickly? It does say 60-minute window. Mhm. We'll know. Modular settlement layer. Intent settlement layer. RFQ systems can and will be external to across, and will have different mechanisms than across RFQ. Okay, so there can be different RFQ systems. So other relays or other people can also use this relay. Okay, next, across implements a specific type of RFQ for across bridge, but any other auction mechanism that produces a transaction or signed order recognized by across spoke pool is supported in across settlement layer. Okay, but any other auction mechanism that produces a transaction or signed order recognized by across spoke pool is supported. RFQ implements specific type of RFQ for cross implements. Okay, if any other, so there can be multiple auction mechanisms ran by some other person or some other network. Like it doesn't have to be a single network. And if it produces a transaction or a signed order, then across settlement layers recognizes it. That's what they're saying. Relays compete to fill the intent order flow and are external to across. Risk Lab. Risk Labs, the team building across, builds and runs an open implementation of a relay to support across bridge and other intent system and accelerate the expansion of relay network. Relays subscribe to and fill orders from multiple systems, have different service offering. Example, same asset transfers via cross-chain swaps and different profit motives. Okay, I have seen this in the relay, and we are gonna try building the relay. Let me just okay, and we are going to try creating a Rust implementation for this relay. Not right now because I don't know any Rust. I'm learning it, but I want to create a interesting project for my portfolio to get a developer job. Right now, I don't have a developer job. I have been working in like tech support and marketing kind of thing, not full on engineering, but that's the idea. Like create an interesting implementation for Relay, um, and maybe there someone will some team will say like, yeah, this guy is good and maybe let's hire him, but I don't know, not right now. After our like whole series are done, we'll do that. Okay, next, settlement is core offering and advantage of Across architecture. Across can accept any cross-chain intent-based order flow and provide settlements, escrow verification, and repayment. Okay. The order only needs to be able to translate it into a structure. Spoke pool recognizes. Across settlement provides two core advantages, which ultimately leads to better execution of intent fulfillment for users and relayers. Okay, this part. Aggregated optimistic verification, as described in step 4 to 6 in the above diagram. Across settlement system aggregates valid fills events off chain to create repayment bundle, which is then optimistically verified by UMA's optimistic oracle. This verification and repayment mechanism scales gas cost of repayment at O of 0 instead of O of n, with number of fills. Okay, we are just bundling it and verifying it. So we have someone is watching on YouTube. Yo, I don't know. Okay, yeah, I was talking about this, right? So we are creating a repayment bundler, right? So that reduces the time for verification. That's what they're saying. And they're using optimistic oracle. So they don't have to wait for transaction confirmation. Like, transaction finality. Instead of doing like a guaranteed finality, they are doing like optimistic finality, where the optimistic oracles from UMA comes into picture. Next, this relayer cross-chain management. With Across settlement architecture, repayment is made on relayer's chain of choice, reducing overhead and complexity of managing cross-chain positions. This lowers cost for relayers, enabling better pricing and execution for end users. It is lowers the cost for relayers, enabling better pricing and execution for end users. It is enabled by Across's hub and spoke model, where LPs extend loan to relayer for taking on time value risk as funds are rebalanced through canonical bridge by protocol. Didn't understand the last sentence. It is enabled by Across's hub and spoke model, where passive LPs extend loans to relayers for taking on time value risk as funds are rebalanced through canonical bridge by the protocol. So there is another bridge, I guess. I think, yeah, the assets need to be rebalanced, right? When you send ETH from Arbitrum to Optimism, it's not actually going from Arbitrum to Optimism. The ETH is going to a contract on Optimism, and someone else is sending their ETH to you on Arbitrum. But actually, it is locked on Ethereum L1, right? So you need to send ETH to ETH L1 and then ETH L1 to Arbitrum. Like, so that's how the rebalancing should work, and that's my understanding. And LPs somehow, LPs extend the loan to relayer. Not sure what these loans are and what is the time. I understand the time value risk, but I don't understand the loan and how it incentivizes the relay. Okay, intent life cycles in across. Yeah, we wanted to create this. I forgot, but we already have the architecture here. Copy image. We can paste it, and we have this. We'll go through all of it afterwards. Each individual component and understand like how it works. We want to understand the spoke pool, then the data worker, how they propose bundler and how they verify it, and what are the repayments or sorry. Okay, not here. I guess yeah, this one. The loans to relayers. Like what are those? We need to understand that in details in next part. Right now we'll focus on our next page, which will tell us intent lifecycle. Intents as a building block. Across is used directly by end user. It can also be used by other protocols to ensure their users' intents are fulfilled. The cross intent structure and life cycle described below is general enough to serve as settlement and communication layer for many use cases. Yes. So what they're saying is we can with intents we can do almost anything, and across a settlement and communication layer is uh, sorry settlement and communication layer can handle most of the use cases. Okay, initiation. The initiation process involves three basic steps. Deposit v3 is called on spoke pool. This call can be made directly by user, but could also be called on behalf of a user by some other smart contract system. This chain, sorry, the chain where this call happens is called origin chain for this intent. The intent specifies destination chain where the user wants to receive the output. We have seen the transaction. Let me paste. Was it? Yeah, switch back. We see, you see, we have deposit v3 as they said. Deposit v3 on spoke pool. Depositor can change. Recipient will be the user, and rest of the things are there. Destination chain ID and is where the funds are going. In our case, it is Arbitrum and Arbitrum Sapolia. Let's cross check Arbitrum Sapolia chain list. Yes, you see, chain ID is same and exclusive relay. It's not there. Ignore rest of the things. That's not important. Okay, next step is users are pulled into spoke. The users are pulled into spoke pool from the caller. Users assets. Okay. Uh, the we need like assets. The user's assets are pulled into spoke pool from caller. These funds are escrowed until the intent is fulfilled, at which point they can be released because cross-chain intents are not atomic. Okay, we already knew that because there is delay between uh, getting finality on one chain and origin and destination chain. That's why there is a delay. Next, because cross-chain intents are not atomic, users' funds must be escrowed before relay can safely fulfill the intent. Understood? The spoke pool emits V3 funds deposited events. Relayers can subscribe to this event to identify intents that they can fill. These steps are intended to be a primitive. Okay. These steps are intended to be a primitive that can fit into almost any system that requires cross-chain transfers. For instance, this design allows gasless order, order systems where users can simply sign order and filler brings in on chain. Uh, just like ERC-4337. In such a system, relays may be pre-selected in off-chain auction to minimize users' cost. Understood? Fill. After initiation, a relay must fulfill the user's intent. This process involves three distinct actions. Fill V3 relay. Fill V3 relay is called on spoke pool contract deployed on destination chain. In this call, the relay specifies on which chain they would like to receive the user's input token. The LP fees that across charges on input depends on this choice. Okay. Generally, if relay takes the input on the chain where user deposited them, the fee is smallest, if not zero. Not really sure. Like, so they are saying if relay tells like I want the repayment on origin chain, then there won't be any fee taken from across. Yeah. Intent is marked as filled in spoke pool. This prevents second relay from filling the same intent a second time. Okay. So relay is basically relay is basically you just listen to an event and call the contract on destination chain and fulfill that intent. But I don't know how sorry, you see exclusive relay, right? So how that this exclusive relay address is set, that's the question. Next, this spoke pool emits filled v3 relay event. These events can be used to track status of intent being settled by the system. They are not used to track. Okay, so it's for data worker. The image we saw, right? We have a data worker. This, I guess that, you see, fill event. So it listens to fill event. Note, intents can have exclusivity period whereby a particular relay address has sole right to perform this during that period. Slow fill or next. Slow fill or expiration if no fill. In the rare case where a fill doesn't happen, there are two fallbacks: an expiration or a slow fill. A slow fill means that a cross system fills the user's sorry. A slow fill means that a cross system fills the user without requiring a relay to provide capital. It's called slow fill because it requires a cross to optimistically verify this fill before executing it, which means the fill happens a few hours after initiation, much longer than typical fill. A slow fill happens when following conditions are met. Input input token and output tokens are same asset. Request v3 slow fill is called on destination chain before expiration time of intent. The slow fill is executed before any relay has filled it or intent expires. Okay, somewhat understood. Just a okay. Back to our mm, page. In cases where a slow fill can't or does not happen, a relay does not fill the intent. The intent expires. Okay, a slow fill, like a slow fill, this expiry must be optimistically verified, which takes few hours. Once this verification is done, the user is then refunded their money on origin chain. Okay. I guess most of the time it won't happen, but that's the case they have to consider while building it, right? Settlement. Once, yeah, this is the part I'm confused about, and also the exclusivity right. That's the part also not explained here. We did have no, we didn't talk about exclusivity in the docs, but there is exclusive relay, right? Control F exclusive. Okay, ignore that. For let's go to settlement. Once an intent has been fulfilled, a cross verifies that fulfillment and releases the input token to the relay. Okay, a cross does this by periodically verifying a bundle of intents. The general process for producing, verifying, and executing bundle is okay. We'll go through this, but one thing is that it takes time when a relay fills an intent. It takes time to get the repayment. Don't know how much, but it does, right? Block range is determined on each chain supported by a cross. The block range goes from end of previous bundles range to recent block chosen by a proposer. I don't know who the proposer is. All fill or slow fill request events in range are validated by ensuring they match, say, they match some deposit event on origin chain. Okay. Third point, all valid fills, slow fill request, and intent expirations are combined to determine an aggregated list of payments that need to be made on each chain. Those payments are included in the bundle. Sorry. All valid fills, slow fill request, intent expirations are combined to determine an aggregated list of payments that. Okay. I just they are aggregating all the events, all the fills, slow fills, and expirations. If funds need to be moved between chains and make these repayments, those transfer instructions are included in the bundle. Okay. Point 5. These payments and transfers are organized into series of data structure called Merkle tree, whose roots are then proposed on chain to hub pool along with a bond. We need to okay, let's mark down all the things that we need to talk about. Exclusive, how exclusive fills relias are selected, question mark. Then what's next? Okay, no, who is the proposer, how much time does it take to get repayment for a relay. Then what was the name? Data worker. What is the data worker? Question mark. Data worker is important. We know it's important, but we don't know what it is. We know how it works, so but yeah. Once this proposal passes the challenge period without once this proposal passes the challenge period without being disputed, the bundle execution can begin. These routes are sent from hub pool to each chain's spoke pool via canonical bridges. Funds are also transferred according to bundle instructions in this step. Once these routes arrive, anyone can execute them to make repayments determined in step 3. Yeah, understood all the settlement steps. The details are not there. That's what is interesting to us, or at least to me. I want to understand the details and how those things work at a core level. Okay, let's intent structure. We have seen it. Advanced field. Okay, we have seen all of this thing. We have one more uh, page to go, but we'll talk about that tomorrow. We don't have enough time to go through the whole page, so let's stop the stream here for today. I hope you guys liked it and understood what I was talking about. And these are the questions we have came up with, and we need to go deep into across and intents to understand how each of those works. So hopefully you are as excited as me to learn about these things, and we'll be here tomorrow, same time. It's I think 2:30 UTC or 8 p.m. IST. Whatever you are comfortable with. I am okay with 8 p.m. IST because I am in Indian time zone. Anyway, if you have any feedback, do let me know in the chat or on Twitter DMs. If you want any notes like what we did or overview of all of the things, you can check link that is in the YouTube description, where there is a Notion page that has all the details about intent acceleration series that I'm doing right now. Okay, I hope you liked it. See you guys tomorrow, same time. Have a nice day. Bye.